Hi, the next section of the work deals with equations of the form y equals mx plus c. Equations in that form are called linear equations because they generate straight lines, or the word line and linear are connected, so that's why they're called linear equations. To sort of develop these ideas, suppose we have an equation of this form, and just to choose a simple example, let's say the equation is y equals 2x plus 5, say. Okay, so we've said in this case that m is equal to 2 and c equals 5. So it's a special case of this equation up here. Now, to draw a line that graph represents, what we do is you just start plugging in some numbers for x, and some simple ones would be, say, x equal to 1, and we plug them into this equation to find out what y has to be. So let's do that. Suppose x equals 1. Y will be 2 times 1 plus 5, which equals 2 1's 2, 7. So the equation up here has generated a set of coordinates which are 1, 7. So what we're saying is that that point satisfies this rule, y equals 2x plus 5. So let's plot that in. We'll just do it really rough. 1, so that's about 1 there. And so 7 is up here. So there's the point 1, 7. Now, let's supposing we plug in, say, x equal to, say, 0. That's a nice simple number. Y equals 2 times 0 plus 5, which equals 5. So the point 0, 5 also satisfies this rule. If x is 0, y is 5. So let's put that in. 0, 5. So it's about there. Let's keep going on this way. Let's put in x equal to minus 1, negative 1. Y equals 2 times minus 1, negative 1, plus 5, which is negative 2 plus 5, which is 3, positive 3. So the point negative 1, 3 also satisfies this rule. So let's put this into the graph. What was it? Negative 1, 3. So here's negative 1 and 3. So that's about there. Now we could keep on doing this. I think we will. Okay. Let's put in x equal to negative 2. Y will be 2 times negative 2 plus 5, which is negative 4 plus 5, which is positive 1. So the point negative 2, 1 also satisfies this rule. Negative 2, 1. Okay, that'll be about there. Now what you can see is that all of these points form a straight line. And the next step is to realize that all of the points on this line satisfy this rule. So what we have is this rule is generating this line. What we can say is that that line is the line represented by that function or rule or equation. So we can label this line y equals 2x plus 5. Now, once we know that all rules, all equations of this form where you've got y equals a number times x plus or minus another number are a straight line, then you can find out what that straight line is by just drawing 2 points. Because if you have 2 points and it's a straight line, you know the line must go through those 2 points. Okay, let's continue with this idea. Suppose we take a simpler case of this equation of the form y equals mx plus c. Let's suppose we put in m is 2 into this and c is 0. So it'll be y equals 2x plus nothing, or y equals 2x. And remember, we know that this is going to be a straight line, so all we need to do is find 2 points. Simple numbers for x are really good to use, so let's put in x equal to 1 and see what that gives us. Okay, y equals 2 times x, but this x is 1, so it's that, which is 2. So the point 1, 2 lies on this graph. Here it is here, 1, 2. Now, another good choice for x is to put x equal to nothing into it. So what do you get in this case? You get y equals 2 times 0, which is 0. So the point 0, 0 lies on the graph. So that's the line which is formed by the rule y equals 2x. Now let's suppose we change it around a bit. Just remember from the last bit that this is the line y equals 2x. Let's suppose we change it from m equal 2, where we had before c equal 0. Let's put in, say, 3 and see what happens. So the rule is going to be y equals 2x plus 3. Okay, now let's suppose we put an x equal to 1 to this and see what we get. It'll be 2 times 1 plus 3, so we get 2 ones are 2 plus 3, get 5. So the point 1, 5 is on the graph, and if we put x equal to 0 into this new rule, we get y equals 2 times 0 plus 3, which equals 3, so the point 0, 3 is on the graph. Let's plot those points. Let's go to new colour. Okay, we're going to plot the point 1, 5 and 0, 3. So along to 1 and up to 5, that's there. And 0, 3, along 0 up to 3, 1, 2, 3, that's there. And what you find is that the line representing that new equation is this one here. So this is the line y equals 2x plus 3. Now what we need to do is to just think about some of the consequences of this. Let's have a look. I wonder what the slope of these lines is. Okay, let's have a look at the slope of this one here. The rise is 2, the run is 1. Rise over run is 2 divided by 1, so the slope of this line is 2. What about this one here? This one here, the rise is 3, the run is 1.5, so it's 3 divided by 1.5. The slope is the same thing. Now, if you work more on this idea, what you'll find is that all equations of this form where the number 2 appears here, in other words, if m is 2, have a slope of 2. So this number here controls the slope or gradient of the line. Now the next thing to think about is that this line here was y equals 2x plus 0. And if you notice where it cuts the y-axis, it cuts it at 0. This one has a 3 there, and if we look at the graph, it cuts at 3. So this number here is where the line cuts the y-axis. We call that the y-intercept. Okay. So to summarize, if we have an equation of the form y equals mx plus c, this number here controls how steep it is. This number here controls where it cuts the y-axis. So for example, if we have a line, let's just make one up, say y equals 4x plus 2, it'll cut the y-axis at 2 and will have a steepness of 4. In other words, it will go up 4 for every one that goes along, so it'll look like this. If you had another line which was, say, y equals 4x minus 3, it would be parallel to this line but cut down here at -3. So this is y equals 4x plus 2, this is y equals 4x minus 3. All lines which have a 4 there will have a slope of 4, and they'll all be parallel. What I'd like you to do now is to have a look at exercise 1D and plough your way through some of those ideas. Good luck.